Hello friends, we are continuing with the video 3 of the 20 videos on data science, and today's topic is going to be on autoregressive model. As you can see on the screen on the right hand side, the blue graph, what you see is a data set from a time series data which is recorded in a sinewave.csv file, and it's able to automatically project or forecast the trend accurately using autoregressive model. Now we are going to see how this is achieved. So autoregressive model uses a time series data set. In our case, it's a distorted sine wave with a lot of fluctuations, to make predictions and also to visualize the results using different lag orders. What is the lag order? We will discuss it now. So auto-regression model, how did the name come from? Auto means self, that is from the existing past values. And regression, as you know, it is a numeric value prediction. Now, a statistical model is autoregressive if it predicts future values based on past values. And it is used only when data is stationary. So, in order to use this, always data has to be stationary. To make data stationary, we have to go through the earlier two videos. If you are not seen that, please go through that, how to make the data stationary. Now, the lag, what is the meaning of lag? Lag 1 means one timestamp shift backwards. Now, lag means number of previous samples to take into account. A lag is a fixed timestamp displacement. For example, given a data set of y1, y2 up to yn, so if someone asks what is the lag between y2 and y7, then it is 5, because this is the timestamp shift. And now we will discuss what is a first order autoregression. If someone writes a1 in bracket 1, that means we will take only one earlier shifted data into consideration. That is lag is equal to 1. So this is a linear model. So y is equal to, it can be expressed as y is equal to mx plus c. M is the slope and c is the intercept. So in our case, the prediction yt is equal to, it depends on the previous one value, one lag, that is yt minus 1, multiplied by a slope and a constant. And m is now known as the autoregressive coefficient. And in any such models, you should always include an error sum. Now, you have to understand what is the meaning of direct and indirect effects. For example, let's say you are doing a temperature prediction problem, and you would like to predict the temperature. What would be the next temperature? To predict the next temperature, you have to consider the previous values. How many previous values you have to consider? Let's consider two previous values. So, which is expressed by yt minus 1 and yt minus 2. And now, suppose yt is only dependent on two previous timestamp, that is yt minus 2, and that is called a direct effect. So, the temperature of today may be dependent on not only day before yesterday's temperature, but there may be an indirect effect. Day before temperature may be affecting yesterday's temperature. Yesterday's temperature may be again indirectly affecting today's temperature. So that is called an indirect effect, and this is called a direct effect. Now, the first order regression in a temperature prediction problem, which we explained earlier, AR in bracket 1, is the temperature of today, that is predicted from yesterday's temperature. Mathematically, you can write yt is equal to C1 plus C2 multiplied by the previous temperature, because we are considering only one temperature, one previous temperature, plus error, of course. And a second order problem, AR in bracket 2 is the temperature of today is predicted from yesterday's temperature and temperature of 2 days before. So it can be mathematically expressed as C1 plus C2 multiplied by previous temperature plus C2 multiplied by temperature 2 days back. So mathematically you can express yt is equal to C1 plus C2 multiplied by yesterday's temperature plus C3 multiplied by 2 days before temperature plus error. Now, what is a lag order? Lag order of AR model tells about how many past values are considered in predicting the future value. See, higher lag order means more and more times in the autoregressive equation. So let's say you want to predict the today's temperature by considering last 1000 temperature, then the equation becomes very big. So the lag order P of the AR model is identified. You have to shorten is as much as possible, and also it should be significant. So to do that, you have to come out with a lag order P, and which is decided using two techniques. It's called autocorrelation function ACF and partial autocorrelation function PACF. And now the lag order P for any model is identified using techniques such as ACF and PACF. And what is ACF and PACF? They are plots used to find relations. ACF takes into account the direct and indirect effect values in previous time lags, both. Now in PACF we take into account only direct effects. Now you can see in this example, so it's let's say a prediction problem, the sales of a company. Now yt minus 1 timestamp before, 2 timestamp before, they are expressed like this. And let's say this is the year and this is the inflation. You would like to predict the inflation 2001. Now when we consider k is equal to 2, that means we are, let's say PACF, I said this is considering only the direct effects. So that means we are taking yt minus 2. That means you have to go back 2 times. So you can see if you subtract 68, if you subtract 68 minus 88, 68 minus 88, that is 2000, that you will write in front of 2000 minus 20, the difference. Again, you can see the difference between 1998 and 1996, that is 88 minus 89, that is minus 1 you are written like this. You recreate a table for k is equal to 2. Now if you plot that, the next column which you got, actually this particular column which you got, if you plot it, you will see graph like this, and this is called a PACF plot. And now in PACF plot, whatever results you got for above plus 10 and below minus 10 only need to be considered. They are only prominent. Others can be ignored. In this particular case, there are 1992, 1996 and 2000 only are prominent. So you can write an equation f of 2001 equal to constant plus the weight phi multiplied by, you are considering 1992 and also considering 1996 and also considering 2000. Others are ignored. So in time series analysis, PACF measures the correlation between a time series value and its lagged values. So autoregressive models predicts the output at a given time as a linear combination of its past values. It means that the future values of the variable are weighted sum of its own past values. So mathematically you can represent it like AR model. Yt is equal to phi1, phi2, phi p, they are all weights, and these are the previous timestamps plus error. So now Auto-regressive coefficients phi1, phi2, phi-p, they are the weights assigned to the past values, and it represents the influence of each past value on the predicted value. Larger values of phi indicate a stronger influence of the corresponding lag time. Now, AR in bracket 1 of the order 1, lag order 1 considers one most significant value, AR2 two such values, three such past values, and like that. Now, once a model is fitted into the data, it can be used to make predictions for the future values by utilizing the observed values up to the order p. So now, in order to test this program, you have to use two such libraries, pandas and matplotlib, and these two libraries will be used in all my future videos also. This is to plot actually. So you are using a state models library, and you are importing auto regression. You can see that, and the first thing what you do is read. You have a data set which is a distorted fluctuating data set. Sinewave.csv is nothing but an Excel file which has the columns which looks like this. It has got 109 rows and one column, and now you have a loop actually, I varying from 1 to 9, and this is used as a lag order which will go into here actually. That means you will, in this loop, you are looping between a lag order from 1 to 9, and you would like to see the effect of lag order, and you will be predicting the values further. I mean, you had up to 109 data, 110 to 160. This many data will be projected and forecasted. So you can see that these are lines for plotting the results, and you can see the results actually. When the lag order is 1, is not able to forecast the trend actually. You can see that it's not good at all. And lag is equal to 2 is also again not at all good. Lag order 3 means, you see the trick, and it is quite intelligent enough to bring back the trend almost actually, not exactly, and this is getting better. Lag is equal to 3. Lag is equal to 4 is even better. 5 is even getting almost similar to the trend which we were getting earlier. Then 6 is even better, 7 is even better, and 8 is even better, and 9 is also even better. Now you will have a lot of a series of videos on this actually, and also the complete Python program is given in the video, and also I will be demonstrating you this program whatever I explained right now. So what I am doing is actually I am going into the Python program, and I am going to just run this program here directly. So I am just opening the Python version, and this computer is a bit slow, please excuse me for this, and I am opening a file which is actually the exact example of this. That is what we are going to explain, we are going to show to you. So I am just going into that directory, and it is going to be this one. So I just open this program. This is what only I explained to you. I am running this program. You can see that. So usually immediately after running this program you start seeing the results, but since my PC is a bit slow, it is taking a bit of time, and you can see that the result starts appearing. For lag is equal to 1 is not able to forecast, predict properly. Lag is equal to 2 is no good. For lag is equal to 3 C is even better. It's actually intelligently able to bring, automatically able to bring back the trend, the sine trend. Then log is equal to 4, even better. Then log is equal to 5, even better. It is almost looking like the same trend. It's able to forecast the trend, predict the trend. Then 6, even better. Then 7 is even better. And 8, even better. And 9 is even better. So that's it for today. So you may see the next videos in my series. Thank you.